Dear all, now we are going to see weight initialization methods in deep learning. So, still now we completed layer wise pre-training. After this topic, we are going to see weight initialization methods. So, what is meant by weight initialization means it is a process of assigning initial values to the weights and bias of the neural network before training begins. Its goal is to prevent vanishing and exploding gradients problem. It speed up convergence, improve model accuracy, and helps the optimizer find a good solution. So while building and training neural networks, it is crucial to initialize the weight approximately to ensure a model with high accuracy. If the weights are not currently initialized, it may give rise to the vanishing gradient problem or the exploding gradient problem. Hence, selecting an appropriate weight initialization strategy is crucial when training DL models. So terminology here is the following notations must be kept in mind while understanding the weight initialization techniques. So fan in means the number of input pass towards the neuron, fan out the number of output pass towards the neuron. So this is the actual representation of fan in and fan out. Three number of neurons which is incoming to the particular node, and two outgoing neurons are there from the out. So why weight initialization is important means consider a neuron. So the activation, before activation, it will be z is equal to w x plus b. W is a weight, x is input, b is a bias. Initially w is unknown. Before training starts, we must assign initial values. If weights are chosen poorly, training becomes very slow, gradients may vanish or explode, the network may fail to learn. So the types of weight initialization techniques, first one is zero initialization. All weights are initialized to zero. So w is equal to 0. So input information will pass to the hidden layer, all weights are assigned to 0. So advantage is very simple. The disadvantages is all neurons produce the same output. All neurons receive identical gradients. Neurons remain identical throughout the training. It's a symmetry problem. So second one is a random initialization. Weight are initialized randomly. Example, we are giving some random values to the weight. So the formula is weight is initialized as random. Usually the range is minus 0.5 to plus 0.5 or minus 1 to plus 1. So advantages here is break symmetry, which is occurred in a zero initialization technique. Different neurons learn different features. Disadvantages large random values can cause exploding gradients. Very small values can cause vanishing gradients. So small random initialization, weights are initialized with small values. So these are the examples which we have assigned very small values as weight. So formula is in normal distribution we are going to range from 0 comma 0.01. Advantages reduces exploding gradients. Disadvantage if two small gradients vanish. So next one is Xavier initialization proposed by Xavier Gloret and Yosha Beggio in 2010, designed for sigma and tangent activation purpose. So the idea is here is maintain approximately the same variance of activation across layers. So Xavier initialization, often termed as Xavier uniform initialization, is suitable for layers where the activation function used is sigma. So the formula here for uniform distribution is minus square root of 6 by neuron in plus neuron out, comma say square root of 6 by neuron in plus neuron out. This is a range for uniform distribution. For normal 0, that means the mean is 0 and the variance become 2 by neuron in plus neuron out. So advantages here prevents vanishing gradients, faster convergence will be there, stable activations are there, best for sigma and tangent activations. So key Kaiming initialization it is proposed by Kaiming he et al. 2015, designed specific for ReLU based networks. So in normal distribution it ranges from 0, 2 by neuron in, and uniform distribution is ranges from minus square root of 6 by neuron in, root of 6 by neuron in. So advantages, it's also prevent vanishing gradients in ReLU networks, faster convergence, most widely used in modern CNNs, best for ReLU and leaky ReLU activation functions. So Leaken initialization developed by Jan Leaken, best suited for ReLU activation. The formula in normal distribution range from 0, 1 by neuron in. Advantages, maintains activation variance, stable learning, best for CeLU. CeLU stands for scaled exponential linear unit. It's also one kind of activation function introduced to make deep neural network self-normalizing, meaning the activations automatically stay close to zero mean and unit variance during training. So orthogonal initialization, the property begins is weight transposition to weight gives the identity matrix. So advantages, it preserves vector lines, prevents gradient exposure and vanishing, commonly used in recurrent neural networks. So last one is identity initialization. The weight matrix is insight to identity matrix. Advantages, preserves input value, sometimes used in residual and recurrent networks. Last one is bias initialization. Zero bias is there. Whenever we are setting bias is equal to 0, it comes in zero bias. Small positive bias means we want to set some small positive value to the bias. So these are the comparisons of weight initialization methods that we have discussed already. So it's compared based upon the formula, activation methods, advantages and disadvantages. So modern recommendations, which activation function is suited for which initialization I have explained here. So this is the summary of this class.